we're going to say that our ambient temperature is equal to 298 Kelvin. That's always a reasonable assumption. We're going to say to turn water to steam, it needs to get to its boiling point, which is normal pressures, is 100 degrees C, which is equal to 373 Kelvin. All right, so we said our specific heat, our specific heat for water is equal to 4.18 kilojoules per kilogram Kelvin. We said our latent heat of vaporization is equal to 2257 joules per gram, and since there's, if you say 1,000 joules and 1,000 grams, they'll cancel out, so this is equal to 2257 kilojoules per kilogram. Don't have to worry about that. And the next thing we need to do is figure out the mass. So I'm going to get a new sheet, and we want to know the mass of the water. So the mass of the water is going to be equal to, well, it's going to be a little bit complicated. So we have 1 gallon. We know we have a gallon. We know, if you look it up, that 1 gallon of water is 8.4 pounds mass, if I remember correctly. Then we can say 1 pound mass is 2.2 kilograms. So you can look these up in your tables, these conversions. This is why I like to use the square brackets, because if I go, this is a volume, I can change volume to a mass, and then I can change the mass to the units that I want, because the units that I want is kilograms. So we'll have 1 times 8.4 times 2.2. 1 times 8.4 times 2.2 is equal to 18.48 kilograms. So these online lecture examples are a lot more work for me, because in class I make the students do all the calculations. Alright, so our energy required is going to be equal to our mass times our specific heat of water times our change in temperature plus our mass times our latent heat of vaporization. So this is equal to, we have 18.48 kilograms times 4.18 kilojoules per kilogram Kelvin times, we have 373 minus 298, that's our change in temperature, plus 18.48 is our mass, kilograms, times our latent heat of vaporization is 2257 kilojoules per kilogram. Yeah, just barely. So if we can say Q is equal to this first bit, 18.48 times 4.18 times, parentheses, 373 minus 298. This is 5,793.5 kilojoules plus 18.48 times 2257 is 41,709 kilojoules. Whoops, kilojoules. So we want to look at the difference between these two. Okay, to raise the temperature, or to raise the mass of water from room temperature to boiling, took 5,000, 6,000 kilojoules. To actually change the phase of the water took 42 kilojoules. So there's a very significant amount of energy required to change the phase of a material. So our total amount of energy, that's a lesson we want to learn for this class, is 5793.5 plus 41 709. That's 47,502 kilojoules. All right, is it reasonable? I want to say, is it reasonable? This is another one where it's difficult to say it's reasonable. I don't know how many of you carry around the amount of energy required to boil water in your head, but we can look at the math and say, all right, we have 20 times 5 times around 100. So 20 times 5 is 100. That does seem a little odd. Let me try again. I'm going to double check this time by redoing the math. So we have 18.48 times 4.18 times 373 minus 298. 5793. Okay, I get the same answer, so we'll say that that's reasonable. And then we'll just redo the other answer. 18.48 times 2257. Same thing, 4179. Okay, so is it reasonable? We're going to say yes. We followed the equation, we put in the right units, check your units, kilograms, cancels with kilograms, Kelvin, cancel with Kelvin, we're left with kilojoules, kilograms, cancel with kilograms, we're left with kilojoules, so we have kilojoules left. Remember, you want to write your units. Units is important.